Week 11, lesson 5. This thing is on sectors and segments. Hopefully this is review from geometry, and I know it's been forever. But anyway, let's talk about some definitions here. So a sector is a region enclosed by two radii and an arc. So in this particular picture, the pink part and the blue part, right, is considered to be the sector. There are two arcs. There's a minor arc, which is this one, which is less than 180 degrees. And then there's this major arc, which is more than 180 degrees. All right. Again, here's just sort of another picture so you can understand the difference between a sector, a segment, and an arc. All right. So now there's a couple of different formulas. If you're wondering why it's spelled this way, this is an IB book that we use, and they use sort of European spellings. It's the plural of formula. All right. Probably the most important thing here is the length of an arc is, again, very, very simple formula, but most important is that angle has to be in radians. If you forget to put the angle in radians, you're guaranteed wrong answers for every single problem. Okay, so let's jump up and start this. Okay, so we're going to find the minor arc length AB. The formula is L equals radius times the angle. Okay, so the radius on this picture is 8. This angle, right, this is the minor arc because it's less than 180 degrees. This is 3 pi over 4. Which, if you multiply together, is 6 pi. That would be considered the exact answer. But if you have that to 3 significant figures and you break out your calculator, you'll get 18.8. All right, and then the area of the minor sector, so let me write the formula up. It is 1/2 r squared theta. So the radius, again, is still 8, and the theta is still 3 pi over 4. If you simplify that and do it exact, meaning you leave the pi in there, you get 24 pi. But if you do it in your calculator and you estimate it to 3 significant figures, you should get 75.4. Okay, now let's scoot this up and we'll do, I believe this is the last example. Okay, so you can pause and read this for yourself, but the first thing we need to do is to find the vertical height of this entire solid, which means I need to know what the radius is here, because that's going to be the same as here, all right? I also need to know what the height of this cone is, okay? Now, we're in luck. This is a 30, 60, 90 right triangle, right? So if you remember the relationship of the sides, since you know the hypotenuse, then you know that the radius is 7. I wish I could write that a little. Let me switch colors. Maybe it'll show it better. Okay, here we go. The radius is 7. So from here to here is 7, which means from here to here is 7. And the height is 7 rad 3. So if you want to know the vertical height of the whole thing, it is 7 plus 7 rad 3. All right, and again, this is all dependent on you remembering special right triangles. If you don't remember them, right, or if they're fuzzy, please ask me in class, or if you're a home learner type person, please ask me on Zoom. Okay, next, part B is saying show that the surface area of the hemispherical base, right? So the area of this part, the surface area of this down underneath part, okay? We're trying to show that is equal to the curved area of the cone, okay? So the hemispherical base would be 1/2 4 pi 7 squared. All right, now you may need to go to the last lesson to get that formula, right? It's not the full area, surface area of the sphere, it's only half of it. That's where this half is coming from. And if you multiply this together, you should get 98 pi. Okay, now if we're going to do the curved area of the cone, that means I have to do the area of the cone minus the base, minus the area of the base. Or in other words, in the formula, you know how there's that part where you're supposed to add the pi r s? We're not going to do that part, right? Because otherwise it would add in the base part, which we don't want. We just want the top part where it says the curved area of the cone. So when I fill in that formula and I put in the pi and the 7 and the 14, we get 98 pi.